This is section 3.3, the rules of logarithms. So in addition to the rules that we had in the previous section, we are now going to add these three. If you have log base A of two things that are multiplied together, then we are allowed to split this up to a plus sign. And of course, these work the other way as well. Notice here that if you're going to start here and then go back to this direction, you have to have the same base before you are allowed to combine them. If your argument is multiplied, you're allowed to split it into two logs added together. If your argument is a division, then you are allowed to split it up with a minus sign in the middle. It's the numerator comes first, and then the denominator is second. Our third rule says that if your argument is raised to a power, then you can take that exponent and move it to the front of the logarithm. So this r moves to the front. And of course, you can also take a number in front and move it up to become an exponent of your logarithm. So let's look at these problems. Given that log base 5 of z equals 3 and log base 5 of y equals 2, use the rules of logarithms to evaluate each of the following. So I have log base 5 of y over z. So I have this division rule. So I convert this to log base 5 of y minus log base 5 of z. Now substitute what we know. Log base 5 of y is 2 minus log base 5 of z is 3. So this would be -1. Okay. Now let's do log base 5 of y squared z squared. This is going to have multiple steps. The first thing I see here is that I have a multiplication. So I'm going to split it up using this property. And I get log base 5 of y squared plus log base 5 of z cubed. Now, because of these exponents, I cannot make these substitutions yet, but I can use this property to move the exponent to the front of the logarithm. So this will become 2 times log base 5 of y plus 3 times log base 5 of z. And now we can make our substitutions. This will be 2 times log base 5, y is 2, plus 3 times 3. So that's 4 plus 9, which is 13. Okay. Now, sometimes we will be asked to write a logarithm in expanded form. That means we just want to separate things as much as possible. In general, when we're expanding, we're going to be starting off on this side and going this direction. We will also later be asked to condense as much as possible, and that's when we'll be starting on this side and going this direction. So I want to expand natural log of 2x minus 1 over x plus 4. This is a division, so I'm going to use this property and separate them using a minus sign. So this becomes natural log of 2x minus 1 minus natural log of x plus 4. And that's actually all we can do with it. Because don't let this mess you up. We are allowed to combine logs that have a plus sign between two logarithms. But we are not allowed to do anything when the addition and subtraction is inside the argument of a logarithm. We have nothing that allows us to do that. So this is as expanded as possible. Okay. So now let's take care of this. The first thing to recognize is that a square root is an exponent. It is a 1/2 power. So what I have is log, this is common log, of 4xy over z to the 1/2 power. Okay, now one of our rules of exponents is that you can take this exponent and apply it to everything as long as it is addition and multiplication only. Additions and subtractions mess this up. But I can change this to log of 4 to the 1/2, x to the 1/2, y to the 1/2, and z to the 1/2. Well, 4 to the 1/2 power, that's the square root of 4, so that's just 2. Okay. Now, my main operation here is the division. So I'm going to split this up using the division property, and I'm going to keep all of this together. I'm going to have to split that up again because it's multiplication. But first, I'm going to take care of the division. So this is log of 2x to the 1/2, y to the 1/2, minus log of z to the 1/2. Okay, now this is multiplication, and even though our property is written with only 2 things multiplied, it does extend to however many things we have multiplied together. So I can split this into 3 logarithms and put a plus sign between each of them. So this is log 2 plus log x to the 1/2 plus log y to the 1/2 minus log z to the 1/2. And now the last thing we need to do is to take all of these exponents and move them down into the front. This doesn't simplify any further. So I have log of 2 plus 1/2 log x plus 1/2 log y minus 1/2 log of z.